My screen is visible to you, class?
No, ma'am.
Not yet, not yet.
Yes.
It is not visible yet, ma'am.
Now my
Now
screen is visible
yes, it is coming up.
and I'm
Yes, ma'am.
navigating. Can you see the slides? I'm navigating.
No,
No,
ma'am.
it is stuck on
The
block
first
Yes.
page
four.
is full.
Yes.
It is still in the first page.
Acha, you are in the first page. Fine. Now is it visible?
I think,
Yes, ma'am.
yeah, because the cursor is moving. Yeah. Yes.
Yes,
Yeah.
it is
Now is
visible.
it visible?
Yes, ma'am.
Yes, ma'am.
Fine, fine. So today we are starting block 4, graph theory. Fine. We are starting with the graph theory. Block 4, Unit 1, basic properties of graphs. In real life, we see many different types of graphs, but we are unaware of what actually a graph is. Fine. Are you able to view this diagram? On the left hand side, figure number 1. Yes, class?
Yes,
Ma'am,
ma'am.
it can be viewed, but it's very small.
Okay, it is very
That could
small.
be, yeah, ma'am. With zoom.
Yes.
Yeah, it is good now. It is good now.
Now it's better.
Are you able to view my diagram?
Yes, ma'am.
Yes.
These are some of the real life examples of graphs. Can anyone state what figure 1 is saying? Yes, figure 1. Yes,
It is showing
figure
a
1.
connected graph.
Yes, our social connectivity.
It's
So
a
our
network.
social, yes, our social connectivity is also in form of a graph. See here, all these are what? All these are the nodes of the graph. These are the nodes of the graph. And what this structure is representing? This structure is representing a graph. In the similar way, if we are having different stores, see diagram 2, we are having different stores and these stores are connected. Fine, these stores are connected. What these stores are representing altogether, they are representing a graph. This is again real life application of graph. At the top, I have one diagram of computer network. Fine. This computer network is also in form of graph. These are the nodes. These computers are the nodes, and these links which are joining the computers are the edges. So I have shown you 3 examples of graph. This will make it very clear that why we use graphs. We use graphs in our social connectivity. We use graph in our telephone network, road network, computer network, electricity network. In all type of networks, we implement graphs. So graphs are very important. Fine. How actually the graphs look? See the left hand side figure. Are you able to view network of nodes? Yes,
Yes,
class?
ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
These small points, these are what? These are vertex. Singular is vertex and plural is vertices. Fine. It means this is one vertex. So this is what? Vertex. And if I am having more than one vertex, then these are known as vertices. So vertices is plural, plural of vertex. Fine. So in this diagram, there are nodes. These nodes are vertex. These nodes are vertex. See red color nodes, yellow color nodes. Fine. These nodes are vertex. Fine. See right hand side. You are having nodes. Fine. These are different nodes. These are nodes. These are nodes. So these are what? These are vertex. These are your vertex. Fine. This is vertex. This is vertex. These are your vertex. And the link that is joining, and the link that is joining them, that the link that is joining them is your edge. It is known as edge. Fine. The link is joining the vertices. This is your edge. This is your edge. This link is your edge. This is edge. Fine. In simpler form, if we see any graph, we find it as a collection of vertex and edges. So these four circle points, these are vertex. This is vertex. This is vertex. And
Ma'am,
this is,
someone is waiting for.
yes, class.
Someone is waiting to join.
Okay.
Let's make one of us a co-host so we can add
Okay.
people.
Okay,
Can,
fine.
so there will be no
Fine.
interruption for you.
Okay. Okay, Mohammed Nazir is co-host. Fine.
Okay, ma'am.
Okay, miss.
Okay. It is clear. You can easily understand graph.
Yes, ma'am.
Okay. Now, what are its vertex? This one is vertex V1. This is vertex V2. This one is V3. And this one is V4. So this graph is having four vertex: V1, V2, V3, and V4. These are vertex. This graph is having four vertex. And what are edges? These links which are joining the vertex. These links are your edges. So this is your edge. These are your edges. Fine. E1, E2, E3, E4. V1, V2, V3, V4. These are our vertex. And E1. E1 is joining V1 and V2. E2. E2 is joining V2 and V3. Then E3. E3 is joining V4 and V3. Then E4. E4 is joining V1 and V4. So E1, E2, E3, E4 are your edges. E1, E2, E3, E4 are your edges. And what are your vertex? V1, V2, V3, V4. Fine. Is it clear? Is it
Yes,
clear?
ma'am. Yes, ma'am.
Fine. So we can say a graph is a collection of vertex sets plus edge set. Vertex set plus edge set. Fine. This is also a graph with one vertex. Graph with one vertex. This is also a graph with two vertex. This is also a graph with three vertex. Is it clear? V1, V2. Here V1,
Yes,
V2,
ma'am.
and V3. All three are graphs. Is it clear, class?
Yes, ma'am.
Okay. These are the graphs. Have you read data structure earlier? Yes, class. Have you heard of data
Yes.
structure? Have you
Yes,
done
ma'am.
data
Yes.
structure?
Yes,
Yes, ma'am.
So you might be knowing tree. So you might be knowing tree. Yes or no?
Yes, ma'am.
Yes.
Yes, ma'am.
So this is a tree. This is a tree. Fine. In left hand side, I have a tree. Okay. This is a tree. And at right hand side, I have one graph. Fine. Can you differentiate between a tree and a graph? At right hand side, I am having a
Yes,
graph.
ma'am. Yes.
Yes. Can you differentiate?
Yes,
Uh,
ma'am.
yes. A graph has a cycle, but tree
Yes.
doesn't have a cycle.
Tree never have a cycle. Never. Never. ठीक है यानी कि no cycle. A graph may contain cycle. May contain cycle. See here. This is a cycle. This is a cycle. This is a cycle. Fine. Is it clear? So graph may contain cycle, whereas a tree will have no cycle. If I create a cycle here by joining these two vertices, suppose this is x and y. I have joined x and y. Now there is a cycle. There is a cycle formed. There is a cycle formed. So this tree is now not a tree. It is now a graph. Is it clear, class?
Yes, ma'am.
Tree is not a tree now. It is a graph.
Graph.
Is it clear? Is it clear?
Yes, yes, yes.
Yes, ma'am.
So every tree is a graph. Every tree is a graph. You may take tree like this. You may take tree like this, or like this. You may take tree like this. There are different forms of trees depending upon its properties. You can have different types of trees. Fine. And these are vertices: v1, v1, v2, v3, v1, v2, v3, v4, v5, v6, v1, v2, v3, v4, v5, v6, v7, v8, v9, v10, v11, v12. All these, all these are, all these are trees. This is tree. This is tree. No cycle is there. No cycle is there. This is tree. No cycle is there. This is tree. Fine. Is it clear? And every tree is a graph. Every tree is a graph also. This is tree as well as graph also. Every tree is a graph. Tree as well as graph also. This is a tree as well as graph also. This is a tree as well as graph also. Fine. Every tree is a graph. Now, see few more examples. First one. Tell me, is it a tree? Yes. Is it a
Yes,
tree?
ma'am.
Yes,
Yes. Is it a graph?
Yes.
yes,
Every tree is a graph. Fine.
Yeah.
Second one. Is it a tree?
No, ma'am.
No, because it is having cycle. Because it is having cycle. This is cycle. Cycle is complete. So it is not a tree, but it is a
Tree.
graph. Third one. Is it a tree?
No, ma'am.
No.
no,
No, because see, cycle is complete. So it is not a tree, but it is a graph. Now you can differentiate between tree and graph.
Yes, ma'am.
So every tree is a graph, but every graph is not a tree. Every tree is a graph. Fine. But every graph is not a tree. Sorry, every tree is a graph, but every graph is not a tree. Is it clear?
yes, ma'am.
See, this is a graph. A, B, C, D. This is a graph, but it is not a tree. Is it clear?
Yes, ma'am.
This is a graph.
Yes,
This is a graph. Fine. But this is not a tree.
Tree.
Is it clear, class?
Yes, ma'am.
Clear?
Yes,
Is it clear?
yes, yes,
Yes, ma'am.
Okay. Okay. And do you know the meaning of connection? Do you know the meaning of connection?
Yes,
See,
means it is.
I am having
There
vertex
is.
V1 and V2. and there is one edge E1. There is one edge E1. E1 is joining V1 and V2. Fine. We were having vertex V1 and V2. And we are having edge E1. Edge E1, which is joining V1 and V2. Which is joining V1 and V2. It means V1 and V2 are V1 and V2 are connected. Is it clear? Class, is it clear?
Yes, ma'am.
Yes, ma'am.
So this graph is known as connected graph. So this graph is known as connected graph. Is it clear?
Yes, ma'am.
So we can define tree. We can define tree. How we can define tree? A tree is a connected graph with no cycles. With no cycles. A tree is a connected graph with no cycles. See, this is a tree. Yes. It is a connected graph. Yes. But it is having no cycle. Fine. See here. A, B, C. It is a connected graph. Yes. Connected graph means you can move from any vertex to any other vertex. See this graph. This is A and this is B. And I want to move from A to B. So is there a path from A to B? Yes.
Yes.
I want to move to C. Is there a path from A to C? Yes. I want to move to D. Is there any path from A to D? Yes. I want to move to E. Is there any path from A to E? Yes. I move to P. I want to move to P. Is there any path from A to P? Yes. Fine. Is it clear? This is known as connected. It means a tree is a connected graph with no cycles. And right hand side I have drawn a graph just to show what connection actually means. This is tree, this is tree. At right hand side I have shown a graph to show what actually connection means. Fine. Is it clear? Now I am drawing some diagram. 1, 2, 3, 4 and 5. This is the fourth one. This is the fifth one. Fine. Just tell me. This is a single node, one diagram. In diagram 2, is it a connected graph or not?
Yes, ma'am, it is connected.
Yes, it is a
Yes.
connected graph because we can move from anywhere to anywhere. Okay. Is third one connected graph or not?
Yes, ma'am.
Is it a connected graph or not? Yes, because we can traverse from any node to any other node. Fine. So it is a connected graph. Let's see the fourth one. Is this a connected graph? Is this a connected graph? Suppose this point, this vertex P. No, we can't move to the P. This is R, S, T. We can move R to S, S to T, but we can't move to P. We can't move to P. There is no edge. There is no edge which can join T to P. It means this node is isolated. So this graph is not connected. Is it clear, class?
Yes, ma'am.
Yes,
So
ma'am.
this graph is not connected. Now coming on to the fifth one. Is this graph connected? P, Q, R, S, and this is T and U. Is this graph connected? This is a graph, but is this connected?
No, ma'am.
No, because let us see from Q to U. We can't reach from Q to U because there is no edge. So this is not connected. So a tree is a connected graph. Now you know what is connected graph. So tree is a connected graph, fine, with no cycles. A tree is a connected graph with no cycles. There will be no cycle. A tree is a connected graph with no cycles. But suppose suppose I join these two vertices. Fine. These are 1, 2, 3. 1, 2, 3. Suppose I joined 2 and 3. Now this has become
Graph.
graph. This is not a tree now. Is it clear, class?
Yes, ma'am.
Okay. Now coming on to graph. Fine. Is this slide visible to all of you?
Yes, ma'am.
Okay. Let us take 2 points, x1 and x2, and join them. We can join in this manner again. See diagram 2. How we are joining these 2 points? We can join these 2 points like this. Now, in diagram 3, let us again join x1 and x2. So we can join in this manner also. It means for joining two vertex, we need a straight line. We need a straight line or a curve. See, for joining 2 points, we need a straight line or a curve. So in 3 ways, we have joined 2 different points. Now let us see few more examples. Suppose you are given 4 points. Fine. And what are the points or the vertex? What are the vertex? X1, X2, X3 and X4. Suppose one way we have joined like this. And the second way we have joined like this. So there are 2 ways. Do these drawings represent the same object or not? Do these 2 drawings represent same object or not? Anyone?
No, ma'am.
Not same object.
Yes.
Because from X4 to X2 there is no connection.
From X4 to
X2.
X2 there is no connection. No. These are, I want to say that whether these set of edges and vertices represent the same diagram.
Yes, ma'am.
Yes. See, from X1 to X2. See figure number 1 and figure number 2. From X1 to X2, there is a edge. From X1 to X2, there is a edge. So see the right hand side too. From X1 to X2, there is a edge. I have highlighted both by green. Fine. Now see from X1 to X4, there is a edge in diagram 1. From X1 to X4, there is a edge in diagram 2 also. I have reflected it with the orange color. Then from X3 to X4, there is a edge in figure 1. From X3 to X4, there is a edge in figure 2. I have represented it with the purple color. And from X2 to X3, there is a edge in one diagram. Fine. And from X2 to X3, there is a edge. I have represented it with the yellow. It means in diagram 1, we are having 4 vertex, X1, X2, X3, X4. Fine. So in diagram 2 also we are having 4 vertex, x1, x2, x3, x4. What are the edges? Edges are x1, x2 in diagram 1. Fine. x4, x1, x3, x4, and x3, x2. In the similar way, in diagram 2, we are having edges x1, x2. Fine. x3, x4, x1, x4, x2, x3. So we can say that these drawings represent the same object. Fine. Is it clear now, class?
So only the
Yes, ma'am.
Only the way of representation is different. Both are representing the same object. Fine. Is it clear?
Yes, ma'am.
Because suppose you are having a graph like this, and you are having a graph like this. Both are same. Both are same. A, B, C, D. A, B, C, D. See, 4 vertices A, B, C, D. Here also we are having 4 vertices A, B, C, and D. What are the edges? Edges are AC. Fine. AB, BC, DC, AD. Fine. These are the edges. Similarly, here we are having edges AB, AC, AD, DC, and so on. Fine. And how we get this diagram? How we get this? We have removed this from here. Okay. You can remove in any way. Let it be here. Remove this one. Remove this one. So this one will become this. Fine. When it was inside, it was BD. When it goes outside, it is again BD. Is it clear? When it was shown like this was the edge BD. When we have made it like this is the edge BD. Is it clear? So
Yes, ma'am.
earlier, which was edge BD is now this edge BD. So it hardly makes any difference if you see any edge drawn like a line or drawn like a curve. Fine. Is it clear?
Yes, ma'am.
Okay, I will draw one more diagram. Suppose this is our diagram A, B, C, D. This is our graph. Fine. And this is the edge BD. Now we may write this graph as A, B, C, D. This BD can be drawn like this. Fine. This BD can be drawn like this. Fine. Is it clear? Both are same. Both the graphs are same. Is it clear? Both the graphs are same. Fine. Or suppose we are having graph like this. V1, V2, V3, V4. V1, V2, V3, V4. Fine. This is V1, V3. But we can draw it like this also. So this becomes V1, V3. Both are same. Both are same. Fine. Is it clear? And both are having same number of vertices and edges. V1, V2, V3, V4 are vertices. Here also V1, V2, V3, V4 are vertices. Here the edges in first figure is V1, V2, V2, V3, V3, V4, V4, V1, and V1, V3. Here also we are having edges V1, V2, V1, V3, V1, V4, V4, V3. Is it clear? Is it clear?
Yes, ma'am.
Both are same. Fine. Both are same. So what conclusion we have drawn? We have drawn conclusion that points are important as objects, but their positions are not important. Is it clear? Is it clear,
Yes,
class?
ma'am.
Is it clear?
Yes, ma'am.
Yes.
It
Yes.
means one diagram was like this, na? A curve or so. It may be like this. A, B, C, D. Don't see whether this is a curve or a line. Fine. Is it clear? Suppose we have 4 points. 4 points are known as, these points are known as vertices. Vertices. Suppose we have points x1, x2, x3, and x4. We have 4 points in a plane, and we have to join all of them at a center place, for example, at x1. So there are different ways of joining. One way is that we join like this. Fine. This is x1. Fine. x2, x3, and x4. We can join like this. So how we have joined? And x1 is the center point. We have other ways also, like x1 to x2, x1 to x3, and x1 to x4. This is another way we can join the points of a graph. This is another way, x1 to x4, x1 to x3, and x1 to x2. So we have seen different ways of joining the vertices of a graph. So these were 3 ways. First one, x1 is at the center, x2, x3, x4. Second way we have seen x1 to x2, x1 to x3, and x1 to x4. Third way, x1 to x3, x1 to x2, and x1 to x4. Fine. And we can say that above three drawings represent the same object. Is it clear, class? Don't
Yes.
see the shape. Don't see whether it is a straight line or a curve. Just see,
The
just
ob-
see, yes, the edges and the vertices. In the first diagram, vertex are x1, x2, x3, x4. Fine. In second diagram, x1, x2, x3, x4. Four vertex. In third diagram, x1, x2, x3, x4. Four vertex. Fine. Now the edges. Now the edges. Edges are x1, x3. Fine. x1, x4. Then x2, x4. In second diagram, see the edges x1, x4. Then x1, x2. Is it clear? Then x1, x3. Fine. In third diagram, x1, x2, x1, x3, and x1, x4. Fine. Fine. So all three drawings represent the same object. Is it clear, class?
yes, ma'am.
Okay. So what is undirected graph? In some graphs, you will see no arrows. No arrows. There are no arrows. But while in other graphs, you will see arrows like A to B. There is one arrow. B to C, we are having one arrow. And A to C, we are having one arrow. So, graph number 1, it is undirected graph. Undirected graph. Graph having no arrow. And second one is directed graph. It is directed graph. It means graph is having arrows. Can you state what is the actual difference? What is the actual difference? It means in graph 1, we can move from A to B as well as we can move from B to A. It means if we write AB and BA both are same. Both are same. Is it clear? Is it clear?
Yes.
But see here in diagram number 2, we can move from A to B. We can move from A to B because there is an arrow showing us the direction. But directly A to B is not B to A. We can't move from B to A because the arrow is showing direction from A to B. Is it clear? Is it clear?
Yes.
So second one is your directed graph and first one is your undirected graph. Is it clear? Class, is it clear?
Yes, ma'am.
So this
Yes,
is
ma'am.
your undirected graph. Undirected graph. There is no arrow. It means AB is same as BA. BC is same as CB. AC is same as CA. Is it clear? And what this graph is showing, that it is a collection of vertex set of G and edge set of G. Vertex set of G is the collection of all the vertices, and here the vertices are A, B and C. A, B and C. And edge set of G is the collection of all the edges. All the edges. So the edges are AB, BC and CA and CA. Is it clear? So we have represented it like this. G graph G is the collection of set of vertices and the set of edges, where V represent the vertex set of G and E represents the edge set of G. Is it clear? Is it clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
And we were saying that tree is undirected graph. We were saying that tree is an undirected graph. In tree there were no arrows. Tree is undirected graph. Undirected graph with no cycles. Fine. Yes. It means in undirected graph, if UV means if UV is an edge, it states that VU is also an edge. है ना? Same. We can represent this like WV or VW. We can represent this edge like UW or WU. Is it clear? Is it clear?
Yes, ma'am. Yes.
Okay. Now coming on to directed graphs. Directed graph. So directed graph will be having arrows. Suppose this is our directed graph. This is A, this is B, this is C. So it will be having arrow. Arrows can be in any direction. Fine. These are, so this is one edge, this is another edge, and you are having direction. It means you can move from A to C. You can move from A to C. Fine. You can move from A to C. Fine. But when you want to move from C to A, you need some other direction. That other direction can be from here. If suppose I am having one edge like this, and arrow is this, then in that case, from moving from C to A, what we will do, we will come here to B, and because arrow is coming here, it means we can move to A. In this way, I will reach to A. Fine. It means here we have AC only. It means AC is different from CA in case of directed graph. Is it clear? Is it
Yes.
this is different and this is different in case of directed graph.
Hmm.
Clear?
Yes.
See example of directed graph. Directed graph. Directed graph is also known as digraph. Digraph. It is represented as G. Again, it is a collection of set of vertices and a collection of set of edges. This is known as vertex set, and collection of set of edges is known as edge set. In see the diagram, we are having vertex x1, x2, and x3. And see the direction of the edges. x1 to x1 to x2, x3 to x2, and x1 to x3, x1 to x3. Fine. So is x1 x2 an edge? Yes or no? Class, is
No,
x1 to
ma'am.
x2 an edge?
Yes, yes.
Yes. But is x2 to x1 an edge?
No, ma'am.
No.
No.
No, it is
No.
directed.
Yes. No. Is it clear? Is it clear?
Yes,
Class?
Yes,
ma'am.
yes, ma'am.
Then let us see the concept of loop. Let us see the concept of loop. What do you mean by loop? In C programming or any other programming language, we use loop. What actually loop means?
The repetition to
The
repeat regular.
repetition.
Mhm.
Yes, while programming for repetition, we use, like number of iterations. In graph theory, if we have one edge that starts from same vertex and ends at same vertex, starts at same vertex and ends at same vertex, then that edge is known as loop. Is it clear? Suppose we are having vertex v1. Fine. An edge is starting from here and it is ending from here at the same at the same point. Then this is loop. Actually, what happens? Suppose e1 is a edge. So this is the start and this is the end. It is joining 2 points. An edge actually joins 2 points. Like we are having an edge e1 and it is joining vertex v1 and v2. Fine. See here in this diagram, u and w, u and w. So suppose this is e1. So e1 is an edge which is joining u and w. Suppose we are having e2. E2 is an edge which is joining u and v. But see, one more edge is there. One more edge is there. This one. And it is starting from point u and ending at point u. So this type of edge which starts from the same point and ends at the same point is your what? Is your loop. So that we can say a loop is an edge that joins a vertex to itself. Is it clear? A
Yes.
loop
Yes, ma'am.
is an edge that joins a
Yes, ma'am.
vertex to itself. Is it clear? U is a loop. See, suppose edge. Any edge joins 2 points. Fine. Any edge joins 2 points. Suppose A, P. This is edge. Edge is joining A and P. Fine. Suppose this is R and S. So see, R and S. This edge is joining 2 points. Normally, an edge joins two vertex, but suppose we are having point X, and here one edge is starting and it is again coming back to the same point. It means this edge is joining X and X. where X and X are same vertex. So this is known as loop. Is it clear? Loop is
Yes,
clear?
ma'am.
Yes, ma'am.
Okay. A graph may have one or more loop. A graph may have, you may see graphs like this. A graph may have one or more loops. There can be any number of loops in the graph. No problem. Depending upon the problem to be solved, it may have many, many loops. So you can have graphs like this: A, B, C, D, E. This is loop. This is loop. Fine. This is loop. Is it clear?
Yes, sir.
This is loop. These are loops. Fine. A graph can have one or more loops. Is it clear? Concept of loop is clear.
Yes, ma'am.
So this is, suppose this is V. So this is representing vertex, sorry, HVV. HVV, start point and end point both are same. Clear? Now parallel or multiple edges. Parallel or multiple edges. Fine. You can see diagram. Can anyone state what actually parallel edge means?
Yes, from Y to X, the two edges are joining.
Mhm.
Starting and ending of foot are the same.
Yes, 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 yes. Suppose any edge, any 2 points are joined by edge. This is edge. E1. E1 is joining A and B. So this is an edge. Actually, in any graph, you will see like this. This is E1. E1 is joining A and B. This is E2. E2 is joining B and C. We are having E3. E3 is joining C and D. We are having H4. It is joining A and D. So simply what we observe that any edge joins two vertices, V1, V2. Fine. For joining two vertices, we need one edge. In some cases where we see that these two vertices are joined by more than one edge, E1, E2. So these edges are known as parallel edges. Parallel edges. Is it clear, class? These are what? Parallel edges. Is it clear?
Yes, ma'am.
Okay. So here we are having vertex X and Y, and see, this is one edge, E1, which is joining X and Y, and we are having another edge, that is E2, which is joining X and Y. That is, for joining X and Y, we are having one edge, E1, and we are having another edge E2. So more than one edge is joining points X and Y. So these are known as parallel edges or multiple edges. Is it clear?
Yes, sir.
Yes, ma'am.
Okay. Okay. So any graph in which we see parallel edges, this graph is known as multi-graph. Multi-graph. And these edges are known as, fine, parallel edges. Parallel edges or multiple edges. Fine. These are parallel edges like E1 and E2. So E1 and E2 are parallel edges. And suppose this is a graph G. Fine. We are having vertices A, B, C, D. And so this graph will be known as multi-graph, because parallel edges are also known as multiple edges. So this is your multi-graph. Class, is it clear? Multi-graph is clear?
Yes, ma'am.
Yes,
Yes,
class, multi-graph is clear.
Yes, ma'am.
That is a graph with the parallel edges. See this graph? This is having parallel edges. Suppose V1 and V2. So V1 and V2 are joined by E2 and E3. See what E3 is representing? E3, E3, E3 is representing V1, V2. What E2 is representing? V1, V2. Fine. It means E1 is connecting V1, V2. E2 is also connecting V1, V2. So E2 and E3 are parallel edges. These are parallel edges. Is it clear? Is it clear?
Yes, ma'am.
yes, ma'am.
Parallel edges can
Yes,
be
ma'am.
anywhere. Parallel edges can be anywhere. You can have parallel edge like this, or you can have parallel edge like this, or you can have parallel edge like this. In your graph, you can also have parallel edge like this. These are parallel edges, these are parallel edges, these are parallel edges, these are parallel edges. In a graph, you can have any number of parallel edges, or you can have a graph where you can have a loop, you can have parallel edges. Fine. You can have any type of graph depending upon the problem to be solved. Is it clear? Is it clear?
Yes,
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 ma'am.
ma'am.
Okay.
Yes, ma'am.
And then if we see any undirected graph, what do you mean by undirected graph?
It doesn't have the
There
direction.
is no
Yes,
arrows.
yes, which don't have direction, which don't have direction. Yani ki where you don't see any arrow, you don't see any arrow. That is what your undirected graph. So undirected graph can be a simple graph where you will not be having any multiple edges. Fine. Multiple edges. So simple graph. Simple. You are having vertex A, B, C, and edges E1, E2, and so on. Whereas undirected graph can also be a multi-graph. It can also be a multi-graph. That is, in your graph, you can see multiple edges. Multiple edges like E2, E3 are parallel edges or multiple edges. So you can see two forms of undirected graph. Undirected graph, one is the simple graph and another is a multi-graph. Is it clear? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Suppose I'm drawing like this. Fine. Tell
Mm.
me, fine. A, B, C, D, E, F. And here V1, V2, V3, V4. This is 1 and this is 2. 1 is which one? Simple graph or multi-graph?
Simple graph.
Simple graph.
1 is simple graph. Fine. Simple graph. And second one is
Multi-graph.
multi-graph. It is
Multi-graph.
multi-graph because it is having parallel edges. Because it is having parallel edges. Parallel edges means those edges which start and end at the same points. Suppose you were having E1, E2, both start at V1 and both end at V2. Fine. Is it clear? Is
Yes,
it
ma'am.
clear?
Yes.
So, how can we define simple graph? Fine. Simple
Ma'am, the
Ma'am,
sound
are
is
you
not.
there? Ma'am, are you there? لکه چې قطع شو څنګه شو
Oh, connection is loud.
Are you able to see the slide?
Yes, ma'am.
We were disconnected.
Yes, sir.
Okay.
Yes.
Fine.
We were in 41 number slide when it was
Very
disconnected.
good. Very good. Yes. Yes. Here, first
Yeah.
diagram, first graph is representing the simple graph. Fine. Why is it simple graph?
It doesn't
Why?
have parallel.
Because it is having no loop. And it is having no parallel
parallel.
edges. Is it clear? No loop and no parallel edges. So it is simple graph. And second one is multi graph. Why? Because it is having parallel edges. Fine. Now we all know that a tree is also a graph. Tree is also a graph. Fine. What is actual difference between tree and graph? See, this screen is visible to all of you.
Yes, ma'am.
Yes, ma'am.
So see,
Yes, ma'am.
this is graph. Fine. And this is tree. That is graph without cycle. Now you know difference between tree and graph?
Mhm.
Clear? Class, is it clear? These are
Yes,
tree
ma'am.
and this is graph. So every tree is a graph.
Graph.
But every graph is not a tree.
Tree.
Clear?
Yes, ma'am.
Yes. This is a graph having two vertex. One is U and another is V. And here we are having this edge. This edge is E. And we have represented this graph as set of vertices V and set of edges E. Fine. Now we can say that this edge E is incident on vertex V and vertex U. Is it clear? Means suppose we are having A, B as vertex and E1 is the edge. So we can say that E1 is incident on or incident with A and B. Is it clear? Where A and B are
Yes.
vertices. Clear?
Yes, ma'am.
And what are adjacent vertices? What are adjacent vertices?
UV.
Yes. In this graph, tell me what are adjacent vertices. What are adjacent vertices? Please identify. BC, AB,
AB,
yes,
DC,
D, AD, fine.
AD.
Adjacent vertices. AB, these are adjacent vertices because one edge is joining them. Fine. BC, BC, BC are adjacent vertices. Fine. Then AB, then AB, adjacent vertices. Then DC, DC is adjacent vertices. Then AD, AD are adjacent vertices as E1 is joining them. Is it clear? Is it clear? Now you know
Yes.
adjacent
Yes.
vertices. Now tell me P, Q, R, S. Tell me what are adjacent vertices?
SP,
SPRQ, SRPQ.
S, R, P, Q, and R, Q.
RS, RQ.
Fine. These are adjacent vertices. Okay. Fine. Is it
Yes,
clear?
ma'am. Yes, ma'am.
So adjacent vertices clear?
Mm.
V1, V2, E1. So we can write E1 is incident on vertices V1 and
And
V2.
V2.
Is it clear?
Yes, ma'am.
HE1, because HE1 is joining V1 and V2. V1 is vertex here, V2 is here, and E1 is joining. So V1 and V2. So we can say that edge E1 is incident on vertices V1 and V2. Is it clear?
Yes, ma'am.
Now tell me which edge is incident on V2, V3,
E2.
E2.
E2. Is it clear? And
Yes,
which
ma'am.
edge is incident on V1, V2?
E1.
E1. Now you know the
E1.
terminology. Fine. Because E1 is joining V1 and V2, and E2 is joining V2 and V3. Is it clear?
Yes, ma'am.
So here
Yes,
I
ma'am.
have written that
Yes, ma'am.
E1 is incident on with U and V. Fine. And U and V are adjacent vertices. Is it clear? Then now coming on to adjacent edges. Adjacent edges. See here. E2. This is edge E2. And tell me the name of this edge. What is the name of this edge?
E1.
E1.
E1. So can we say that E1, E1 and E2 are adjacent edges?
Yes, ma'am.
Yes.
yes, ma'am.
Yes. Because they have common vertex. Is it clear? Means adjacent edges have common vertex. Common vertex. Is it clear? Have at least one common vertex. For example, A, B, C. Now, see E1, E2. Are E1 and E2 adjacent edges? Tell me.
Yes, ma'am.
Yes.
Yes, ma'am. B is a common
Yes.
vertex.
Because B is a common vertex. Fine. So we can say that E1 and E2 are adjacent edges. Is it clear?
Yes,
So we
ma'am.
can say E1 and E2
Yes,
are
ma'am. Yes.
adjacent edges. Fine. This is the diagram. Here we are having U, V, X, and Y. These are your vertices. Fine. And this is directed graph or undirected graph?
Directed.
This is
This is
directed.
directed.
graph.
Directed.
Okay, okay. Now check whether UV and VX are adjacent. Check UV. UV is this one,
Yes,
and
ma'am.
VX. VX is this one. Fine.
Yes, it
VX
is.
is this one. And they both have one vertex is common, that is V.
V.
So we can say that yes, UV and VX are adjacent edges. Is it clear, class?
Yes, ma'am.
Yes,
Okay.
ma'am.
And can you tell me any one non-adjacent vertices? Non-adjacent vertices. Any pair of non-adjacent vertices.
In this graph,
Means
Yes,
XY.
yes. For example, see here, V
Y
and
and
Y. V and Y.
V and
XV.
V
U
and
and
Y.
Y.
They are not connected.
XV.
Yes, they are not directly connected.
XV.
Non-adjacent.
YU.
Fine. Yes. See the adjacent ones, it means they are directly connected. Suppose we are having V3. So V1, V3 are non-adjacent vertex. Is it clear, class?
Yes,
So
ma'am.
Yes,
V1,
ma'am. Yes.
V1,
Yes, ma'am.
V3 are non-adjacent vertex because they are not directly connected. Is it clear?
Yes, ma'am.
Yes.
Okay. So in this graph, how many vertices and how many edges are there? First, let us count the vertex. Fine. X, Y, V, and U. So how many vertex?
U.
Four.
Four
Four.
vertices.
Four. Four.
Four
Plural of
vertices.
vertex is vertices. So we are having four vertices. Four. And how many edges? How many edges?
I think 7. One,
Okay.
2, 3, 4.
Seven.
Seven.
Yes.
You can
Yeah.
count in any way, na? It is
Seven.
because it is directional. So I have counted like this UV. I have counted like this UV. Fine. UV. Then UX. I have counted like this, huh? UX. Then UY. 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 Okay, then VX. Now you can count VX. Fine. So whatever is the number of edges, you can write here.
8.
This is the way we can count. Simply move to the direction where you want to move because this is a which type of graph?
Directed.
Directed.
Directed graph. Fine. Is it? Okay. Then I want to show you the structure of molecules. You must have studied hydrocarbons. Hydrocarbons means the compound that are made of hydrogen and carbon. Carbon is represented with C and hydrogen with H. So let us see the structure of butane and isobutane. The formula is C4H10. Let us see how they can be represented with the help of graphs. Is this screen visible to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
C4H10. See the how graphically they can be represented, butane and isobutane. See 1, 2, 3, 4. These are the nodes. These are C4, C4. Now H10 in this way connected. These are the simple bonds and they are represented in form of a graph. Fine. So these are nodes. These are nodes, H atoms. They are forming nodes. So this is one way of representing. Another way for isobutane, because the bonding is like this, so we have represented graph as per the bonding in its structure. So in this way, carbon is attached to hydrogen, and this is represented with the help of graph. Is it clear? Is it clear?
Yes,
Yes,
ma'am.
ma'am. Yes.
For showing
Yes.
the bonding between the atoms, We have shown it in the form of graph. Fine. Now we know many types of graphs. Now coming on to one more type, that is
Complete graph.
complete graph. Fine. What do you mean by complete graph? Complete graph. It means any two vertices are adjacent. Any two vertices are adjacent. Fine. Any two vertices are adjacent. See, vertices are A, B, and C. See, A. A is adjacent to B and C. Yes. A is adjacent to B and C. Yes. See B. B is adjacent to A and C. Yes. C. 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 C is adjacent to A and C is adjacent to B. Yes. So any two vertices pair are adjacent. Is it clear? This is a complete graph. This is a complete graph. For example, let's take a graph with only one vertex. As we are only having one vertex, so it is a complete graph. Let us take a graph with two vertices, v1 and v2. The number of vertices n. So when we were having only one vertex, the graph was known as k1, that is n is equal to 1. When we are having two vertices in a complete graph, that is n is equal to 2. N means number of vertices. So it is represented as k2. See here, k2. From v1 to v2 there is a way. Yes. From v2 to v1 there is a way. Yes. So this is a complete graph with two vertices. Now coming on to complete graph with three vertices. 3 number of vertices. So graph can be represented as k3. K3. Suppose we have vertices A, B, C. Fine. AB is adjacent. Yes. AC is adjacent to each other. Yes. For B, check. BA, yes. Adjacent to each other. Yes. BC, adjacent to each other. Yes. For C, check. CA, yes. And CB, yes. It means this is complete graph. Is it clear? It is clear, class. Is it clear? Complete graph.
Yes, ma'am.
And this is
Yes,
a
ma'am.
complete graph with three vertices. Complete graph with three vertices. Therefore, it is represented as K3. 3 stand for number of vertices. Now coming on to K4. K4 means 4 vertices. Here the vertices are A, B, C, and D. So for A, check A to B, check A to C, check A to D. How you will check? A to B, yes. A to C, they are adjacent, yes. A to D, they are adjacent, yes. Is it clear? Now we will check for B. B. B A, B C, B D. We will check for A. Okay, fine. We will check for B. B. B A, B C, B D. They are adjacent, yes. Now we will check for C. Now we will check for C. Fine. C A, C B, C D. Okay. C A, C B, C D. Yes. Is it clear? Is
Yes,
it
ma'am.
clear? It means
Yes,
we
ma'am.
can say that this graph is a complete graph. Fine. Is it clear?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
We have proved that this is a complete graph. Okay. Now I am taking this out like this. So the graph will now become A, B, C, D. Fine. And it will be like this. It will be like this. Now check whether this graph is a complete graph or not.
No, ma'am.
Hmm?
No, ma'am. There is no edge between A and C.
A and no. Keep AC. Keep AC. Then tell me.
Then
Check
it
for
is.
A. First check for A. A to C is here. A to B is there.
Yes.
A to D is here. Fine. A is clear. Check for B. Check for
BC,
B. B to C is
BC,
B to
BC,
A and B to D.
B2
Is it clear? So
is,
B
yes,
is okay. B is yes. From B we are having other adjacent vertices. Now check for C. Check for C.
CE,
CD,
CAC, BCD.
CA
Yes, it is.
and CB. Fine. There is no problem.
No.
C is also okay. Now check for D. Check for D.
DC,
D, B,
DB,
D, C and D, A.
A.
So it is also okay. It means this is also a complete graph. Is it clear?
Graph.
And
Yes,
both
ma'am.
are similar. Both are similar.
Similar.
Fine. Have you seen a computer network?
Yes, ma'am.
The computer network makes practical use of complete your graph. Fine. In computer network, we have different forms of topologies. Have you studied those topologies?
Yes, sir.
Yes, we studied.
Yes. And do you remember?
Yes, star topology.
Yes.
Okay. Star topology.
Mesh topology.
So this is what?
Okay.
This is a graph. This is a graph.
This
Is
is
it
star
clear?
topology.
Is it clear? A, B, C, D, E. So this is what? This is a graph. Fine. Like I have shown here. This is a graph. And see the interesting feature. This vertex V1, it is adjacent to V2, adjacent to V3, adjacent to V4, adjacent to V5, and adjacent to V6. This is your star topology. Then which other topology you are having? Ring
Ring
topology.
topology.
Ring topology. Do you remember?
Yes,
Ring
ma'am.
topology. This
Yes,
ring
ma'am.
Yes,
topology
ma'am.
is like this. So again, it is in form of graph where the
Yes.
vertices are V1, V2, V3, V4, V5, V6, and V7. And these are the edges. These are the edges. Is it clear? Can you state VC is adjacent to which other vertices?
V7, V5,
Yes, VC is adjacent to V7 and
and
V5.
V5.
Is it clear? And
Yes, ma'am.
V3 is adjacent to which other vertices?
V2,
V2
V4.
and V4. V2 and V4. So here we are having a cycle on 7 vertices. The total we are having 7 vertices and we have a complete cycle. That is what we are having ring topology. So the ring topology is also representing a graph. Then we have tree topology also.
Yes, ma'am.
Fine. We have tree topology also. So tree topology is representing one of the form of graph, that is tree. That is graph having no cycle. So it is also a graph. Is it clear? Then what other topology you were having?
Bus.
Bus topology. Fine. You were having bus topology like this. Fine.
Yes,
And
ma'am.
what else? Mesh topology.
Elaborate.
Mesh topology.
Mesh topology. Fine. And see the mesh topology. Mesh topology. Mesh topology. So any connection is missing or everyone is complete?
Complete, I think.
No, complete.
Yes. So is this representing your complete graph?
Yes.
Is mesh
Yes,
topology
ma'am.
representing the complete graph?
Yes.
Hmm?
No, I
Suppose
think.
this, yes or no?
Yes, it is connecting with each
Yes,
other.
Yes,
ma'am, but
ma'am.
as of now, in this graph, one edge is
Yes.
missed. E to C is missed.
Yeah,
E to
E to C is
E
missing.
to C. Let me see. E to C. Yes. On any other? Any other which is missed? Fine.
No.
Now it's okay.
Let us see. Let us see. Let us take A. Let us take A. And from A C, A to E, A to D, A to C, A to B.
B.
Fine. A to B, C, D, E. Now let us see B. Let us see B
B.
and check A, C, D, E. Now B. B to A. Fine. B to E, B to D, B to E. Yes. All are adjacent. Fine. Now
Yes.
we have to check for.
D.
Now we have to check for
C.
C. C. Let us check for C. A, C, B, C, D, and C, E. Now check for now C.
D.
Yes. C to A, C to B, C to D, and C to E. Good. Now what we have? We have D. So check from D to C, D to B, fine, D to A, and D to E. Now we have left E. So E to A, E to B, E to C, and E to D. It means this is what? This is a,
Complete.
yes, this is
Complete,
a, yes, complete
Complete
graph.
graph.
complete graph.
Yes, every vertex is adjacent to every other vertex. So mesh topology is also representing graph. Fine. And how many vertices are there in this graph? 1, 2,
1, 2,
3,
20,
3,
4,
20.
5. So
Five.
K5. Okay, it is K5. Is it clear, class?
Yes,
Yes.
ma'am.
It is K5. Any other graph you know?
Hybrid, no. In
Yes,
topology,
hybrid.
it was hybrid.
Hybrid. Yes, hybrid.
Yeah.
So hybrid represent our network, our road network. Hybrid represent our road
It's
network. है
complex.
ना? Yes. Somewhere we have like this. Then somewhere we have like this. Fine. Somewhere we have like this. So hybrid means collection of two or more types of networks. Fine.
Yes.
So this represents our social network or our road network. So this is what hybrid network. Okay, this is also in form of graph. Is it clear, class?
Yes, ma'am.
Then
Yes.
what do you mean by disjoint graphs? Disjoint graphs.
Incomplete graph, I think.
Disjoint graphs.
Incomplete graph, I think.
Yes. See, suppose you have one component of graph, this, and another component, this. This is the first component of a graph, and this is second. And this is your complete graph. Complete graph. And it will be known as disjoint. 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 Fine. Because from any vertex here, you can't reach to G or H. So this is what? This is disjoint. Is it clear?
Yes, ma'am.
And what is connected? Connected if it would have been like this. It means from any vertex of the graph, directly or indirectly, I can visit any other vertex.
Ma'am,
From any
hybrid graph is, I think it's incomplete graph.
Which
Hybrid
graph?
graph. Hybrid.
Hybrid graph is incomplete. Yes. Hybrid graph is incomplete because every two vertices are not adjacent. This is adjacent to this only. This is adjacent to this only. This is incomplete. Fine.
Okay.
But this is a graph. Is it clear?
Yes.
Obviously, this point, it is adjacent to only these two. Nothing, no other node. This is adjacent to only these three. That's it. Fine. This one is adjacent to only these three. Is it clear? This is adjacent to only these three, these four. Clear? This is
Yes, ma'am.
adjacent to only these. So incomplete graph, but again it is a graph. Incomplete graph, but a graph. Is it clear, class?
Yes, ma'am.
Yes, ma'am.
Disjoint. Now you understand disjoint.
Yes, ma'am.
Yes.
This is disconnected. If I say I want to move from A to G, I can't move because there is no H. So this is what? Disjoint. Fine. So disjoint graphs. Disjoint graphs. Yes. Disjoint graph. Suppose I have one graph in which I have vertex A, B, and C. Fine. And I have another graph in which I have vertex D, E, F, G. Fine. So in one graph, I am having vertex A, B, C. And in another graph, I am having vertex D, E, F, and G. So what is VG? VG is vertex set of graph 1. It is A, B, C.
C.
And what is vertex set of another graph? This is the graph G. This is second graph. This is H. So vertex set is D, E, F, and G.
G.
Fine. So is there anything common?
No.
No. That is why null set. When there is nothing common, then we can say these are disjoint graphs. Disjoint graphs. Fine. You can represent G here, H here in the Venn diagram. Fine. G is A, B, C, and H is D, E, F, G. And there is nothing common. So we can say these are what? These are disjoint graphs. Is it clear? Is it clear? Disjoint
Yes,
graph
yes,
is
yes.
clear.
Yes, ma'am. Yes, ma'am.
Yes.
This is your disjoint graph. Are these disjoint? No. You are having common vertices. Fine. When you are having common vertices, you can't say it as disjoint. Now coming on to complement. What do you mean by complement? You have studied in set theory. Let us see. In Venn diagram, this was your A. So what was your A complement? This was your A complement, and this is your universal set. Is it clear? Now here in graph
Yes, ma'am.
theory, how will you denote the complement? See your graph number 1 on left hand side. Fine. X1 is connected to X2. Fine. Fine. X2 is
Yes.
connected to X3, X3 to X4, and X4 to X5, and X5 to X1. Fine. So
Yes.
what will it be its complement? What will be its complement? Its complement will be just opposite. It means there should not be X1, X2. There should not be X2, X3. There should not be X3, X4. edge, and there should not be x4 x5 edge, and there should not be x1 x5 edge. It means here as x1 and x3 are not connected, so in your complement x1 x3 should be there. Is it clear, class?
Yes, ma'am.
Yes, sir.
See there, here in left, see x1 x3 is not connected. Fine, but see right hand side x1 x3 is connected. Is it clear? See
Yes,
left hand side x2 and x4 are not connected, but see right hand side x2 and x4 are connected. Fine, is it clear?
Yes, sir.
See
Yes, ma'am.
x5 and x3 are not connected, but see here x5 and x3 are connected. Fine, see x1 and x4 are not connected, but right hand side see x1 and x4 are connected. Fine, is it clear? Here x5 and x2 are not connected, x5 and x2 are not connected, but see right hand side x5 and x2 are connected. Is it clear?
Yes, ma'am.
Yes.
It means it means it means it means suppose this is a graph. Fine, and here BC are connected, so it means in its complement BC should not be connected. Here BA are connected, in its complement BA should not be connected, but CA is non-adjacent, so here CA should be adjacent. Is it clear? Here BD are non-adjacent, so here BD should be connected. In this way you can create the complement of a graph. Do you know how to make complement of a graph?
Yes.
Okay, so let us take my previous example. This was the example: A, B, C, D, E. Remove this, remove this, remove this, remove this, and remove this. What you have to do? You have to join A with C. Fine. C with A. Is it clear, class? Is
Yes,
it clear? You have to join like this. Fine. So C. Fine. This is your B, C, D, E, and A. Now complement is clear or not?
Yes, sir.
And this AB is removed. See, AB is removed. This BC.
Yes, opposite of that.
Yes, BC is removed. Fine. This CD is removed. ED is removed. AE is removed. Class, is it clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Now
ma'am.
you know how to form the complement? How to form the complement?
Yes, ma'am.
Okay. You can create complement V1, V2, V3, V4, V5. Fine. You are having V5, V4, V3, V2, V1. I don't need V5, V4. Fine. I need V5, V3 because it is not present in my own graph. So I need V5 to V3. Okay. I don't need V3, V2. No. I need V1 to V4. So V1 to V4. Is it clear, class? I need V4 to V2.
Yes, ma'am.
V4 to V2. I need V1 to V3. V1 to V3. Fine. Is it clear? Is it clear?
Yes, sir.
Yes, ma'am.
I need this
V2,
V5 to I need V5 to V2. Yes. And all existing edges are removed. It means these adjacent vertices should not connect with each other directly. They should not be adjacent in your complement graph. Like V2, V3 are adjacent here. They should not be adjacent in the complement graph. Is it clear? But here V4 and V2 are non-adjacent. So we have to connect V4 and V2. We have to make here, here, here. V2 and V4 are non-adjacent, and we have to make them adjacent in the complement graph. Is it clear? Class, is it
Yes,
clear?
ma'am.
Yes,
Any
ma'am.
problem? Is it
No,
clear?
ma'am.
No, ma'am.
Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Everyone?
Yes.
Okay.
Yes, ma'am, it's
Yes.
clear.
Okay. What is degree? What is degree of a vertex? Yes.
It is the
What is
number of
degree of a vertex?
edges connected to that vertex.
Yes. That is number of edges incident with x. Number of edges incident with x. Suppose I am having x. Fine. And these three edges like E1, E2, E3 are incident with x. So what is the degree of the x? 1,
It
2
is 3,
and
ma'am.
3. So degree of x is equal to 3. Is it clear? Is it clear?
Yes, ma'am.
Degree
Yes.
of x is clear. Now
Yes,
let us
ma'am.
see one example. Now let us see one example. V1, V2, V3, V4, V5. Tell me the degree of every vertex. Tell me the degree of every vertex. So what is the degree of V2?
It is 4, ma'am.
Yes. 1, 2, 3, 4. So degree of V2 is 4. Now what is degree of V5?
It is 2, ma'am.
So,
Yes.
It is 2
What is
only.
degree of V5? 1, 2. So degree of V5
And 2.
is 2. Yes. So what is degree of V3?
It is also 2.
1, 2.
2.
And what is degree of V4? 1,
It is
2,
3, ma'am.
3. Degree of V4 is
2
3.
and 3.
Is it clear? Is it clear? Degree is clear?
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now we have handshaking theorem. Handshaking theorem. Now let us see what it states. It states sum of degrees of the vertices, sum of degrees of the vertices, sum of degrees of vertices of graph G is twice the number of edges, is twice the number of edges. Sum of degrees of the vertices is equal to the number of edges, twice the number of edges. Can you prove this?
yes, ma'am.
It means sum of degrees. Sum of degrees matlab you have to count degree. V1 ki degree, then V2 degree, then degree of V3, and then degree of V4, and it should be equal to twice the number of edges.
Yes.
Twice the number of edges. Let us say our graph, this one. Fine. What is the sum of the degrees? V2, it is 1, 2. V1,
2.
1, 2. V3, V4, 1, 2. And so we are having total count of the degree is
8.
8. It should be equal to twice the number of edges.
Edges.
Twice the number of edges. And how many edges are there? This
4.
E1.
4.
Yes. This is E2. This is E3. And this one is E4. So we are having 4 edges. So 2 multiplied by 4. Fine. 8 is equal to 8. So this is your handshaking theorem. Is it clear? What
Yes,
it
ma'am.
states? Sum of degrees of the vertices of G is twice the number of edges. Is it clear, class?
Yes, ma'am.
Okay. Suppose we have this graph. Can you find the total of degrees? Total sum of degrees? And can you prove that it is twice the number of edges? Let me label the graph. A, B, C, D, E. Yes, let me see who finds first. Total of degrees. 1, 2, 3. 1, 2.
Yes, ma'am.
1, 2, 3,
It's
4.
7.
1, 2, and 1, 2, 3.
Total 14
14.
degree. Yes.
14. है ना? Count like 1, 2. Add this 1, 2, 3. 1, 2, 3. Then 1, 2, 3. 1, 2. 1, 2, 3, 4. Add all this 14 is equal to twice the number of edges. The number of
Edges is
edges.
7.
Yes. E1, E2, E3, E4, E5, E6, and E7. That is 7. Is it proved? Yes.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Fine. I think this is clear now.
Yes, ma'am.
Yes, ma'am.
Yes.
Then
It's clear.
coming on to regular graph. Regular graph. Fine. Regular graph. Can you state what is a regular graph? Yes. Suppose this is a graph. Fine. And these are vertices A, B, C, D. See what is the degree of each vertex? For A, what is the degree? What is degree of A?
2.
2. What is degree of B?
2. All
Two.
are 2.
Yes. Yes, 2. What is degree of C?
Yes, 2.
And what is degree of D?
Yes,
2.
2.
Fine. When the degree of every vertex is same, then that graph is your regular graph. Fine. Is it clear?
Yes, ma'am.
Is it clear?
Yes, ma'am. Yes, ma'am.
Can you give example of any such graph? Can you give
Rectangle.
example of
Yes.
any such graph? These are
Yeah.
vertices A, B, C, D, E, F, G. Fine. See the degree of each vertex. 1, 2, 3.
3, 3.
1, 2, 3. 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Is it clear?
Yes, ma'am.
Regular
Yes,
graph is
ma'am.
clear?
Yes,
Yes or
ma'am.
no?
Yes,
Now I will give you 2 examples. You have to find whether these graphs are regular graphs or not. Fine. See carefully the example, then answer. Okay? Will you try?
Yes, ma'am.
Yes, ma'am.
So these are the graphs. let me draw the first graph. This is the first graph. Fine. Just tell me whether this is a regular graph or not.
It is a regular graph.
Not
These are the vertices from A to J.
It is a regular graph, ma'am.
Yes.
This is regular. Yeah.
Every vertex has
regular?
a
Every-
degree of 3 edges.
Every vertex is having same degree.
3
Three.
degree.
Yes or no?
Yes, ma'am.
Yes,
Everyone having three bets.
Have you checked? Everyone?
Yes, ma'am.
Fine. So it is 2 regular, 3 regular, or 4 regular graph.
3 regular.
Degree of each vertex is
3.
degree of each vertex is
3, ma'am.
3.
Is
Fine.
3.
Now let me take another example. This is clear. I think this is clear.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So let me take this example. Yes. Tell me whether this is regular graph or no or not. Are the degrees same or not?
1, 2, 3. 1, 2, 3. 1, 2, 3.
E, F,
1,
G, H,
2,
I,
3.
J.
Yes, ma'am.
Yes, it is.
Yes or no?
It is.
Everyone?
Yes, it's
degrees.
Yes, ma'am.
it has 3 degrees.
It is a regular
All
graph.
has 3 degrees.
Clear?
All the vertex has
Clear?
3 edges.
Now let me give you one more example. One more example.
Ma'am, let's check.
I will give you one more example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Fine. You can draw like this. And these are the vertices 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, this is also a graph. Tell me,
It is not regular, ma'am.
Yes, ma'am, it's the graph.
yes or no?
It is not regular
It's a
because
graph, yes.
the vertex 12 has only 2 edges.
Vertex 12?
Yes.
Yes, vertex 12. Tell me,
Vertex 12
vertex
has
12.
only 2. Vertex 12 has only 2 edges.
Yes, yes.
But
I have ignored here, na? For creating some error, I have ignored here. Fine. Otherwise, I would have drawn it. I want to know whether you are taking it carefully or not. Fine. That is why I have ignored this. Okay.
Yes.
If two,
Okay,
if
ma'am.
12, if
Okay.
12 number node would be behaving like other nodes, then it would have been a regular graph.
It is
Fine.
very grass.
Is it clear?
हाँ जी.
I have made slight modification. Now, what is a subgraph? What can be a subgraph, class? What can be a subgraph?
Part of a
It is part of a complete graph.
smaller
Yes.
graph.
Yes. What is a
Part of a
subgraph?
smaller graph.
Yes.
It's a part of complete graph.
Yes. Okay. suppose I have one graph like this: A, B, C, D. Fine. Can I say that graph 2 is subgraph of graph 1? Can I say? Can I say?
Yes, I think. Yes, the edges
Yes,
Yes,
sir.
ma'am.
same.
Yes, ma'am.
Yes, because number of vertex is same. Number of vertex are same. Okay? Number of vertex are same. Yes. Yes.
Yes, ma'am.
If any component is removed, then what we get? We get the subgraph. Is it clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Tell
Yes.
me, is every graph subgraph of itself?
Yes,
Yes.
ma'am.
Is every graph a subgraph
No,
of itself?
ma'am. No, ma'am.
Why?
It would be a subgraph because whenever you are removing any edges, so it represents the subgraph.
It can be. In set theory, you have written power set of A, na?
Yes.
Power
Uh-huh.
set
Yes,
of A,
ma'am.
yes or no?
Yes, yeah.
You have written, na? And all the elements were there. Suppose a set is having elements 1, 2. 1, 2, 1, 2. Yes or no? And you have
Yes,
written a
ma'am.
set,
Yes.
yes or no?
Yes.
Yes,
Yes,
ma'am.
ma'am.
Yes. Fine. So every graph can be a subgraph of itself. Fine.
Hmm.
Ma'am, but as you said there that one component, if n
Lekin
component removed, then
yes,
it could be a subgraph of what
but
original
proper
graph.
subgraph. But proper subgraph. For proper subgraph, what we do? We simply either try to remove one edge, one or more edge. Okay, remove one or more edge. For proper subgraph. Fine. For example, let me show that this is a graph. Fine. And if we remove these edges, then the graph, this is proper subgraph. Fine. Proper subgraph. Then there can be another case. For this graph, I can form subgraph like
Januar failu na ikhaber tarana oda.
this can be subgraph A,
Failu na
B,
ikhaber tarana oda.
C, D. Fine. A, B, sorry,
Male failu na ikhaber tarana oda.
A, D,
نزيل مايك دي خلاص هو.
صغير
B, C.
بانك ده.
Fine. Is it
Derzatu
clear?
bakhe.
So graph 2 is subgraph of graph 1. Is it clear?
Yes.
Yes, ma'am.
Yes,
This is
ma'am.
again subgraph.
B.
Fine. Is it clear? So I will give you one assignment. May I give you one assignment?
Yes, ma'am.
Yes, ma'am.
Find all possible subgraphs of this graph. This is a graph G. It is having vertices 1, 2, 3, 4, and you have to find all possible subgraphs of graph G. You have to find all possible subgraphs of graph G. Fine. Secondly, just try to find out whether this is a complete graph or not. Just try to find out whether this is a complete graph or not. Have you drawn this diagram? Have you drawn this diagram? Class,
Yes, ma'am. Yes.
have you drawn it?
Yes, ma'am.
Okay. Just prove that sum of degrees of all vertices is equal to twice the number of edges. And I am giving you one graph. This is your graph, fine. And what is this? A, B, C, D, E, F. Fine. You have to prove that sum of degrees of all vertices is equal to twice the number of edges. Done? Fine. And
Okay,
next,
ma'am.
you have to identify the type of graph. This is the last question. You have to identify the type of graph. Type of graph. You have to write which type of graph it is. A, B, C, D. It is having multiple edges. This graph
Parallel graph.
is having loop, self loop. Fine. And this is the graph which is having directional edges. Fine. And this is the graph. You have to identify the types of graphs. And last, you have to identify the types of graph. Fine. Is it clear?
Yes, ma'am.
Yes, ma'am.
Fine. So today we have started the graph theory. We have seen the difference between trees and graphs, different types of graphs, different operations to be performed on the graph, handshake theorem. Fine. Connected graphs, regular graphs. Is it clear? Subgraph. Fine.
Yes, ma'am.
So let us end the session now. Fine.
Ma'am, if you don't mind, I need to ask something regarding the contents.
Fine. Fine.
Ma'am, there is an application, IGNO application, e-content here. And also LMS, we have the same with the LMS, the subjects are equal or no, because I'm using that application and I'm downloading that subjects from the IGNO e-content applications, and also I'm studying that one.
Fine.
So is the LMS and also the IGNO e-contents application software are same?